In the previous video, we've been talking about how to go from base 2 to base 10, but what if we want to do the other way around? So what if we want to go from base 10 to base 2? This is actually pretty straightforward as well. So let's just suppose that we have 7 in base 10 and we want to go to base 2. What I'm basically going to do here is divide 7 by 2, which is the base I'm targeting. And I'm basically going to see whether I get a number that has no numbers after the dot. So whether it's an integer or not. So I'm just going to show you what I mean. So I suppose we have 7 and we want to go to base 10. I'm going to do 7 divided by 2, which is going to give me 3.5. Well, for the American among you, this is the European notation. So if I write 3 with like that, I basically mean 3.5. So this is basically what I mean. I know I should write a point, but this is the European notation. So just keep in mind that I basically mean 3.5. So 7 divided by 2 is going to give me 3.5. So I know that the first number is 1. If it was going to be, I don't know, like 3 without the 0.5, then the very first number was going to be 0 instead of 1. So this is basically how it works. You basically divide the number you get by 2 over and over again until you get 0, and you basically check whether you have an integer or not. If you do have an integer without any rest, so like 3, then the very first number is going to be a 0. If you instead have 3.5, so something like dot 1, dot 1, 2, dot 3, so something like point something, then you're basically going to get a 1. So let's just go and continue the process. So we're just gonna keep the 3 and the integer part here. We're not gonna keep the dot 5 and the 0.5 part in this process. So we're basically gonna get 3 divided by 2 is gonna give me 1.5. So the second number is 1 because we still get a 0.5. So we're basically going to take 1 divided by 2, going to be 0.5. So the third number is 1. So basically 7 in binary is 1, 1, 1. So this is basically how it works. You get the very first number divided by 2 over and over again until you get 0. And you basically check whether you have an integer or not. If you do have an integer without a point something, then the very first number is going to be a 0. And the second one is going to be a 0 and so on. If you do have a point something, then the very first number is going to be 1. So in this case, we basically got 0.5, 0.5, 0.5. So it's going to be 1, 1, 1. And 1, 1, 1 is binary, especially 7 in base 10. Let's crack on with another example in which we're basically going to get 0. So let's start with something else, like, I don't know, something to get a 0. Well, 12 in base 10. So we basically got 12 in base 10, and we want to know what it is in binary. So let's just divide it by 2 because this well, we are basically targeting binary, so base 2. So 12 divided by 2 is going to be 6. So the first number is 0. So 6 divided by 2 is 3. So the second number is 1. And then we have 3 divided by 2 again is gonna be 1.5. So the third number is 1. Oh, I'm sorry, this is 0. We're just going 0 because we basically got a 3. So 1 divided by 2 is going to be 0.5. So the fourth number is 1. So 0, 0, because we basically have two integers, so 6 and 3, 0, 0, 1, 1, because we basically got a 0.5, 0.5 here and here. So 12 in base 2, which is binary, is 0, 0, 1, 1. So 0, 0, 1, 1. So 0, 0, 1, 1. So this is basically how it works. You get the first number, they basically give you in base 10, you divide it by 2, which is the binary, the base 2 you're targeting, and you check whether you get an integer or not. If you do get an integer, then the first number is 0. If you do get the integer, the first number is 0. If you do not get an integer, then the number is going to be 1. You do it over and over again until you get to 0. So in this case was 0, 0, 1, 1, and the other case was 1, 1, 1. So I hope it helps as always. And sorry for the boo-boo basically made here. So it happens. Anyway, as I said, I hope it helps, and stay tuned.